All right. As it says here, reactions is the heart of chemistry. Without reactions, we're just talking about elements and things in a kind of a static way. It's in reactions where we actually start looking at chemical changes and how things behave and actually doing something useful with chemicals rather than just simply naming them or figuring out their electron structure. So, parts of a reaction. There are two parts of a reaction. The left side of the arrow, this side over here, and the right side of the arrow. So the left side is called the reactants. It's what's doing the reacting. And then the right side is the products. It's what's being produced or being made. Okay? So reactants and products. So what you just saw there is what we call a formula equation. It is written with the chemical formulas and an arrow to separate the two sides from one another. We can also have what we call word equations, where we use words to describe it. So an iron nail reacts with oxygen in the air to produce iron oxide, rust. And we use words like make, form, produce, or yield in place of kind of where the arrow would be. So you'll kind of see both. All right, and then we also have what are called state symbols. These are used in formula equations, and they help us to understand what state something is in. So for example, a solid, okay, it makes a difference whether we're talking about solid iron or molten iron. A liquid, we got liquid butane here, C4H8. Gas, okay, those are your most common, solid, liquid, and gas. And then we have what are called aqueous, and aqueous means dissolved in water. So for example, sodium chloride, when it is melted, melting salt takes incredibly high temperature, thousands of degrees, for it to finally melt, as opposed to simply dissolving it in water. And we're generally talking about ionic compounds, but other things can be dissolved in water too. But in terms of chemistry, we oftentimes will take ionic compounds, which are solid at room temperature, and we're going to dissolve them in water, creating what we call an aqueous solution. Okay, which means dissolved in water. And then the last one is what we call a precipitate. A precipitate is in certain types of reactions. We're going to take a liquid or a solution and a solution. We're going to mix them together. And then all of a sudden a solid is going to be formed. And it's basically going to look like that solid is raining out of the solution as it settles to the bottom. Or instead of raining, we would say precipitating. Because that's what we call things that fall out of the air, right? We call it precipitation. The rain or snow, we call it precipitation. In this case, it's a solid falling out of a liquid. We call it precipitation. Okay? And its symbol is PPT, and done like that. I've also seen it done as just an S. I've also seen it done as a down arrow, depending upon what your book does. Okay. So state symbols are often used when we're converting a word equation into a formula equation. So that iron nail, the iron is going to be a solid. The oxygen is a gas because it's in the air, and we're making iron oxide, which is a solid because it's ionic things tend to be solids, unless they're dissolved in water. All right, so state symbols, you'll see them. Some cases are really important, sometimes not. So sometimes you see them, sometimes you don't. A lot of times you don't. But when they do show up, they're generally there for a reason. All right, the other big thing that we need to talk about in terms of doing or dealing with reaction basics is what we call diatomic elements. So notice that in this previous example, like it just says, I've got O2 written in the formula. It's not O. I just said it was oxygen. Why is it not O? Well, that's because oxygen is what we call a diatomic element, meaning that in its natural state, in their elemental state, they always come in pairs. Hence, di, meaning two, atom, diatomic, come in pairs. And there are 7 of them: hydrogen, nitrogen, oxygen, fluorine, chlorine, and bromine, and iodine. And there are 2 ways to memorize this. The way I learned in school was this one, Harry Broncliffe as a name, so H. Broncliffe. So hydrogen, bromine, oxygen, nitrogen, chlorine, iodine, and fluorine. And then I had, once again, the teacher I did my student teaching with, the way she did it, she said you look at element number 7 on the periodic table, which is nitrogen, and make a 7 and add hydrogen. Okay, so start with element 7, make a 7, and then add hydrogen. Okay, so nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. And so that is your reaction basics. So you need to be able to identify reactants and products. You need to be able to go back and forth between a word equation and a formula equation. That's why the nomenclature stuff's important. And then we need to be able to know about diatomic elements and state symbols. So that's your basics. And now we'll move on into balancing in the next lesson.